Now here is yet another interesting variant of the Minesweeper where the clues cannot be taken at face value. There's something going on there. Notice we call this as the multiple variant. When I create this, it doesn't form as a regular grid. In fact, it forms like a game of chess. You notice that every alternate square is a pink square. Now, the way this game works is that if a mine happens to be in one of these pink squares, its score is taken as 2 times the actual score. So we'll see this in action that will become more clear. Let's say I click on this. Okay, so that's 2. All right, so let's hope to open something. Okay, so now this is good, right? So now we know that this is a mine over here, and this is not a mine. This is also not a mine. This is not a mine either. In fact, none of these are mines. Now we know that this is a mine. So far, everything looks quite normal, uh, but just matter of time. So this is a mine. So this is not a mine. 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 Um, in fact, this is also not a mine. None of this is mine. Right? Notice something very interesting happened here. I get a value of 2 coming from all these cells, but there's only one possibility here. The reason it's showing 2 is because, like I said, when I have a mine in a pink square, then its value is taken as 2 times. So that's why all of this is showing 2. This is showing 3 because, well, 1 coming from here and 2 coming from this. So it's telling me 3 mines. I can't take this as face value exactly. However, this is a mine. Now we can move forward. Let's look at, let's say, this corner. Uh, so here is telling me 2, but the only way I can have a mine here is this, and that makes sense because if I have a mine here on the big square, this value will be taken as 2. Now I have a 3 here and a 4 here, which means, so I already have a 2 from here and I've got a 1 on this. Okay, so this is very interesting. Now I've got a 1 over here, which means one of these two cells has to be a mine. Can't be this because if this was the case, this would be 2. So this must be a mine. Now, given this is 2, this is 1, this is not a mine. This is also not a mine because 3 is already taken care of. And in fact, I can go and open up all these 3. Now I've got a 1 over here. This seems reasonable. So this is not a mine. All of this opened up. I've got a 2 over here. Okay, so the only way this can be 2 is because this must be a mine. So pink gives me square of 2, score of 2. So that is 2. Okay, so now let's look at this. So I've got a 4 over here. In fact, 2 plus 2, because remember, value of this is taken as 2. So this cannot be a mine. So I will open this up. I will now, so I've got already a 2 here. So this can't be a mine. Now I've got a 5 over here. So let's think about this carefully. But okay, anyway, let's move forward. This is not a mine. I've got a 2 over here. In fact, I've got 2 in all of this. So this square is interesting. If this is a 2, the only way it can be 2 is if I have a single mine over here. So this must be a mine. This must not be a mine as a result because this was also 2. This 2 is also satisfied. So this also must not be a mine. And in fact, I managed to solve the problem. Now notice this is showing me a 4 because, well, 2 and 2 from both, right? So like I said, the numbers are not exactly what they're telling them to be. Anytime a bomb or a mine lands on, let's say, a pink square over here, its value is counted twice of what it is. And that's why we are calling it a multiple variant. Now, again, we are going to build this by modifying our existing project. So few obvious changes. We are going to call this, instead of liar variant, I'm going to call this multiple variant. I'm going to create also a global variable which controls the game flow. So let's just do those basics first. So I get back to my code over here. Just like liar variant here, I create say a multiple variant and I set it true. Now, for now, I'm going to set the liar variant to 0 so that, combining the two, I think will be very, very confusing. But, so if it's not a liar variant, I'm playing the multiple variant and I will just go and say liar. I can search for this. Okay, so here instead of liar variant, I'm going to call this as a multiple, variant. So that's like basic stuff. The labels will change, but now obviously the display of the buttons should also change. Basically, wherever I create these buttons, and then we'll talk about the field later on, but wherever we create the buttons over here, now I've got to ask myself a question that, look, previously in the regular game, all the buttons looked totally, let's say, like each other, all gray in color. But now, depending on the type of the game, we have to decide whether every alternate button should look a little bit different, let's say. Now, when I want to do this, so I just ask myself a question. Well, look, if it is the multiple variant, so I set up the entire board, but then I ask myself a question: is if this is a multiple variant? Remember, multiple variant is a global, also a boolean. So if it's a multiple variant, well, every alternate cell becomes, let's say, pink. So I can do that by looking at the column and the row index. So if let's say KK2 is 0, which means I'm in an even row and an odd column, and JJ percentage, let's say 2 or modulo 2 is equal to say 1. Well, then B, say BG is equal to say pink. Likewise, if say, you know, exactly the reverse situations, KK modulo 2 is equal to 1 and JJ modulo 2 is equal to 0. So if this is the case, BG is equal to also pink. So basically, if the multiple variant is set up, then the board sets up, in the right colors. But more importantly, here we need to update the value of the field. Now remember this. Now remember, in this case, now there is no layer variant going on, which means the display field can be same as the field. But however, I will change the field itself. When I create the field, I will make sure that every mine contributes to the correct score, which means if a mine lands up on a on a pink square, then its value is taken with a multiple. So that is what I'm going to do. So I get to my function called update field, and here I'm going to make some changes. Let's see. Remember, the way it works is I go to every mine. These are all the locations of the mines. I find out all the neighbors, and on every neighbor, I increment the value of the field by 1. Now, in this case, field and the display field can be exactly the same. So what I need to do really is that I need to figure out if I have a bomb which is on the, let's say, pink location, then instead of increasing by 1, I'll be increasing it by 2, which means by a multiple. So multiple is what I need to decide. And the way I can do that is I know where my mine is. So for example, over here, so I basically find, before I find the neighbors and stuff, I know where, let's say, so this was a mine, I found a mine here. Just going to ask myself a question. Look, if multiple variant is set up, um, then I'm going to just ask myself the same question once again. Am I on one of those cells? So, I can do that by finding out log xy is 0. That's, remember, the row index of the particular mine. Modulo 2 is equal to 0 and log xy, say 1. Modulo 2 is equal to 1. So if this is the case, well, multiple, uh, so I just define a variable called multiple, for example. Multiple becomes 2. On the other hand, if it's exactly the reverse of this, which means log, so again, let's say multiple will become 2. Okay, so here, if this is 1, but this is 0, so it's like even row, odd column, an odd row, even column, right? Something like that. So in this case also the multiple is 2. Okay, be a little bit careful here. Else the multiple remains 1. So everything plays as usual, right? So multiple, say multiple is equal to 1. Now, if the multiple variant itself is not set, well, in that case, definitely the multiple is equal to 1. So I find my neighbors and I, then update the field exactly the way we were doing. However, instead of doing it by 1 here, I'm going to say 1 times the multiple. So that takes care of, the different scenarios. Basically, if the multiple variant is not set, then the multiple becomes 1. Also remember the display field, which is where display is going to happen, will end up being same as the field, because remember my layer variant has been set to 0. So when I, let's say, run this piece of code. Okay, so there's one more thing I need to do when I reset the board. Remember, when I reset the board, again, the same concentration comes in. So I'm just going to, basically I go up here, the reset. So when I reset the board, previously I'm setting the colors to, let's say, 0, 0. I'm sorry, color back to gray, but I can ask myself this question. Look, if say multiple variant, if this variant is set up, well, if then KK modulo 2 is equal to 0 and JJ modulo 2 is equal to say 1, If this is the case, well, I'm going to config the color. Uh, so instead of this, I'm going to just say, well, set it back to pink, for example. Um, say, okay, I put an elif over here. And that should be okay. So now when I, and everything else should basically run fine. So when I run this piece of code, so first so it says multiple variant, exactly what I wanted. So I say 9, 9 and say 10. I create this, I make this a little bit bigger. Now the important thing I want to see is if I were to look at my list field right now. So, I've got, let's see one of these, right? So basically my case, so I've got a mine in this cell, right? So that is 0029. Look at this cell. Around it, there's only one mine in the neighborhood. Look at this one here. So, this 9. ah, so this 9 over here, notice, which is here basically, there's only this mine which is on, but every cell is showing 2 because notice this mine lands up on a on a uh, let's say pink cell, right? Likewise, look at this one over here. There's a mine over here. We know this. Now these are showing me as 3, even though so there's one mine here. These two mines here, basically third row. So these two are mines. Field is showing as 3 and 3 because 2 from here, 1 from here, right? So with this, we can just kind of try to play this. Okay, so very, very unlucky. I just happened to pick a wrong mine. Now let's look at this. So I'll not display the field this time around. Let's try to play this. Okay, so all right, so this is nice. Now this corner, only way I can have a mine is here, and this is on a pink square, so this must be a mine, and I'm getting counted 2 for this, right? Now here I've got a 2 again because taken care by this, so this must not be a mine because 2 has already been accounted for. So when I do this, okay, now this is telling me 4. Let's look at this. So this also must not be a mine. Okay, this also must not be a mine. None of these should be mine. So in fact, a lot of things open up now, right? So now this is a 4. The only way this can be 4 is that there's a 2 coming from here. There must be a 2 coming from here as well. Here's the 3. So this must be a mine because 2 plus 1. Likewise, this cannot be a mine, right? And this is 1. That's okay. So this is not a mine. Here I have a 4, but this is not a mine. I know that. Okay, this is giving me a 6. So I have got 2 mines. So this is 3. So the only way I can get a 6 is, well, this must be a mine, and also this must be mine. So basically 2 plus 2, that's 4, and 5 and 6. So that's why I get a 6 over here. Now if this is the case, then this cannot be a mine, right? So I will click this. Yeah, now this must be a mine, so be careful. So this must not be a mine. I'm getting a 3 over here. Okay, let's look at this. So this must be a mine because that's why I get a 4 over here. So I get this as a mine. This is not a mine. This is not a mine either. This must be a mine. And if this is a mine, then, well, none of these are a mine. So this opens up quite a bit. In fact, now we should be able to solve this. So I've got a 4 over here. 2 comes from this. Another 2 must come from here, right? So I've just got one more mine left. I've got a 2 already taken care. This can't be a mine. This is a 4. This must be a mine. When I click this, I think I have won the game. And indeed, I have. Now, this shows me a 2, remember, because this is a pink square. A mine here counts for 2 points. Very, very interesting. Notice how the clues are no longer now to be taken at face value. There, the value depends on the positioning of the mines. And again, see how, we used our existing infrastructure to build this game without disturbing the existing features, right? So if we just want to go back to the original game, we can just set the multiple variant off and we'll be through to the next variant. I mean, through to the next normal game, right? I hope you found this interesting. And in general, this way of learning is very, very effective. Look at our website, www.ybyte.in, because we learn Python programming through such fun activities. Take care. Thank you so much. Bye-bye.